Alright, so welcome to my newest version of the malware class, guys. So good to see everybody back. Everybody in the class is pretty much an old veteran. Makes me so happy to see all you guys here. So let's get in here and let's get going, okay? So we've got the paste bin. Here's the paste bin. So capital Q, capital X, capital U, capital R, capital D, lowercase z, lowercase m, capital A. Let's get in here and let's do this. Okay, so I'm going to jump down to the desktop. Okay, I want to grab these files. I've already got these files from 18 and 19 on my desktop. And then I've already got this file unzipped. But you should be doing these commands. So cd to your desktop. wget these two files. Then unzip this file. The password is going to be infected, all lowercase. Okay, so immediately what we want to do is we want to use the file command. So let's say, for example, you collect malware, however you collect it. Maybe you collect it from your anti-spam software. Maybe you run some software like Message Screen or Barracuda or Ironport or some sort of message screening software that usually sits in front of your mail server. And it cleans up a lot of the spam and all that. And it collects suspicious files. Maybe you get your malware that way. Maybe you have a proxy solution. Foolproof, Blue Coat, WebSense, Dan's Guardian, Squid, some sort of proxy solution that monitors traffic. And maybe you scrape files from there. Maybe you have your antivirus quarantine system. Maybe you have something like that, right? So maybe it's your McAfee, your Trend Micro, your Symantec, your one of those Sophos or one of those types of products where you collect all of those pieces of malware. Maybe you do that. Maybe you run something like Network Active that takes PCAPs, network PCAPs, and pulls file types out of network packet captures. It doesn't really matter how you get your hands on these files, but the ways that I just listed are some common ways that you get your hands on files. So maybe you grab all those files and then you periodically drop them to a directory here on your Linux machine. And the first command that we run against it is the file command. So Linux has a command literally called file. And what it's going to do is it's going to give you the file type. So you see here that I said file, malware.exe, and it's letting me know that it's a portable executable. So it's 32-bit PE file. Doesn't exactly have a rename command. What we generally use is the move command. So now I did have a case where the file was an exe file. It's now a PDF file. Now you see that I run the command again and it still tells me that this is a portable executable. And the reason for that is because Linux actually reads the header of the file. The extension of the file. So if we look here on line 32, what do I mean by the header? If I hex dump and grab the first couple of bytes, you see here that I've got a 4D 5A, and then I've got an MZ 4D 5A. So let's go look that up. You'll see that we've got a good reference for that here on line 36 of the paste bin. So let's jump over, let's take a look at that. Once we get on this page, I'll do a Control F and I'll just look for MZ. And you see down here that I find MZ. I find that 4D 5A. Now any file that's a COM, a DLL, a driver file, an EXE file, a PIF, a QTX, QTS, or sys file, he's letting you know that that is a Windows DOS executable file. This I did not know. These are the initials of Mark Zybkowski. Never knew that. The designer of the DOS executable file format. I learn something new every day. Well, I look at this site a couple times a month. I did not know that. Learn something new every day. Okay, so like I was saying, every file has its file header, and the file header is how the Linux operating system determines the file type as opposed to Windows. Windows uses the extension to determine the file type. So let's say, for example, if the file is a PDF file, what you'll see in the header is two files. So really, after a while, what you're starting to realize is your forensic software. This is what your forensic software and antivirus uses to figure out file types, do file recovery, and do signature type stuff, right? A lot of stuff is going to be based on the header. And if you're going to be doing a lot of malware analysis, you're going to want to get comfortable with the structure of a PE file header because you're going to be looking at it a lot. You're also going to see that it gets mangled a lot. A lot of people like to mess with the PE header when they're modifying files, specifically to avoid detection. All right, so our next command that we want to run is called objdump. Objdump. So objdump is short for object dump. So I'm going to run objdump -x against malware.exe. So objdump -x against malware.exe. So the first command that we ran was the file command. The second command that we're going to run is the objdump command. So I run objdump and get all this stuff. Looks like we have a question. Okay. Patrick's having bad audio. Are you guys getting bad audio from me? Oh, everybody. How about now? Is that better? Now it sounds like someone's drilling. Oh, now it's clear. Keeps going in and out. Intermittent jackhammer. Are you serious? Hmm. Let me switch my internet. You know what? Here, let me do this. I was teaching a class the other day, and they told me it was better if I dialed in. Let me dial in.
Okay, is that any better? Much better. Now sound like Barry White. Okay. Okay, so back to class. All right, guys, so like I was saying, we ran the obj dump command, short for object dump. So you see that it gets all kinds of information. So let's take a look at it. Okay, so we ran obj dump -x. We can see the file format for PE I386. We can see here a couple of things, right? Relocations have been stripped, line numbers have been stripped, and symbols have been stripped. This is definitely a case of a file that's been modified. Now, oftentimes when you see stuff like this, back in the old days, people did this kind of stuff because they were trying to make the file smaller. So you were producing a file. After you compiled it, you were trying to get the file as small as possible. So you remove some of this stuff. You remove relocations. You remove symbols. It doesn't affect the functionality of the program, but it certainly makes it a little bit harder to analyze. So people started to do it for a couple of reasons, making the file a little bit smaller at compile time and making the file a little bit more difficult to analyze because if you were releasing production software that you were trying to sell, you really didn't want too many people reverse engineering it and stealing your intellectual property. Well, hackers have taken the same trait. Because they don't want you analyzing the malware that they create. They often do a lot of these little things, stripping relocations, stripping line numbers, removing symbols. Now, you're going to see a lot of reverse engineers show you how to use IDA Pro and WinDebug and download the symbol data from Microsoft so that they can rebuild some of this symbol information. Okay, so here you see the date and timestamp of the file. Here you can see the linker version. Things that I'll be conscious of. Everything in here is spoofable. So when you see it says linker version, that's the compiler version. Now remember, all of this stuff is spoofable. A person can take a hex editor and change all of this stuff. Okay, the next thing that I think is really important to notice from this data is right here, the DLLs. Now, once you can see the DLLs, we use the DLLs themselves to figure out what functionality that the tool has. So, kernel 32 is going to be a real generic DLL, but ws2_32.dll, we want to look that up. So what you're going to do is you're going to take that DLL and you're going to Google the DLL. Here we go. You see that it says the Windows socket library ws2_32 is required by Windows applications to handle network connections. That's really interesting. Okay, now when they start giving you this other data, someone's got a piece of malware named after that DLL. Don't get me wrong, I'm not saying that that's not important, but what we really care about is this part right here. So Windows socket library. Now that we know what this DLL is used for, we can understand the functionality that this file has because this DLL is in use. So we know that this file is network aware. This file is capable of communicating with the network. So the next command that I want to run is the strings command. Now what the strings command is going to do is the strings command is going to take any ASCII data out of this binary file. So I've got a binary file. I'm going to take this ASCII data from it. So what I want to do is I want to run strings against malware.exe. And then when I do that, you're going to see that I get a whole bunch of gibberish. So as I go through the file, I get a ton of gibberish. So you see all this gibberish throughout the file. Now what's really important to me is at the very bottom of the file. Here. Okay, so here's the stuff that we have down at the very bottom of the file. The first readable thing that we have is our two DLLs, kernel32.dll, ws2_32.dll. Now what I want to do is I want to look up this next thing, this load library A. So I look up and I see that there's load library A, and you're like, man, what is that? And you're going to see that this load library function loads a specific module into the address space of a calling process. Okay, now that kind of makes you like, huh? Basically, load library A and load library EX are how Windows does DLL injection. So if you have a running process and you need to add new functionality to a running process, you're going to use either load library A or load library EX. So load library A and load library EX. So these are going to be things that we're going to look for because these will be telltale signs that we are loading new functionality into a current running process. Right here, here's EX, load library EX. And the other one is load library A. So if you can load a DLL, if you can load a DLL, then what you can do is you can say, okay, I have a current running process, and I want to add functionality to that running process. Okay, see it? In runtime dynamic linking. Load library A, load library EX, there's another one too, load library something else. It's like load library W. But these are ways that you can load functionality. Now here, you see what it says? Look, after the DLL is loaded, the module calls the get proc address function to get the address of the exported DLL functions. The module calls the exported DLL functions using pointers returned by get proc address. This eliminates the need for an import library. Now, isn't that interesting? Because you see there's load library A, and there's also get proc address. So when you load this functionality into memory, you're going to use get proc address to see the address of where that functionality is now located. So now we say, okay, my next one is virtual protect. What's that? So virtual protect is for memory management. It's how you set permissions on a particular area of memory. So you want to change the permissions on something, you're going to use virtual protect. Now here, you're going to see this. All pages in the specified region must be within the same reserved region allocated when calling virtual alloc or virtual alloc EX. So you may need to allocate memory for this DLL to be loaded. So you basically carve out some space for where you're going to load something. Then you load something into that space. Then you use virtual alloc to allocate. So you go, okay, let me use virtual alloc to allocate some space. I use virtual protect to change the permissions on the space. Maybe you want to make it read, write, execute. And then when you're done with it, you can use virtual free to get rid of that space. And then if you want to load libraries into that, that's what load library A is, and then exit process is how you kill itself, right? So you're seeing here that just based on this little bit of information, we know that it's network aware. It has the ability to add functionality to itself. That's what all this is. So it can load new functionality to itself. Now we don't see something like GDI.exe, graphic display interface, or GDI.dll or something like that. So we can infer that it's probably a command line executable. Doesn't really open up a GUI or anything like that. And again, we would know that based on the DLLs that are in use, right? We don't see any DLLs that indicate that it has a graphic user interface. So we can see what the command line utility that connects to the network and loads functionality to itself dynamically. So it's most likely a bot. So it's most likely a piece of malware that when it opens up a beacon somewhere, pulls down instructions for what it's supposed to do, a bot. So let's go for a couple of these. Let's run the strings command, and let's grep. Grep-I is for insensitive, a case-insensitive grep. So we're going to grep-I for DLL. So you'll see that we come up with some DLLs. So kernel32.dll, ws2_32.dll. We can see those are the DLLs that are in use. We can grep for the word library. Now we can see that load library A is the library that's in use. We can grep for the word reg. Now we can see that this has the ability to edit the registry. Okay, so now we know the file is network aware. We know that the file can load functionality into itself, and we know that the file is capable of editing the registry. So we can look for some particular registry keys, right? Right, not seeing anything. Okay, so I don't see any particular registry keys that it seems to update right away. So we might have to run it to get that kind of information. So why don't we grep for IRC? Definitely see IRC in it. So why don't we grep for some IRC commands? Yep, definitely looks like it has the ability to join a channel. So what's going on with IRC? Well, IRC is Internet Relay Chat. So years ago, what you used to have, before Instant Messenger and Twitter and all that kind of stuff, we talked on something called IRC, Internet Relay Chat. And we would use Internet Relay Chat as a means of talking. So you'd be in a chat room. So let's say you were in a chat room and the chat room was called malware analysis. So you would /join #malware analysis is what you would do. And then once you got into the channel, you would get an @ by your name if you were the first person to join the channel. Now, other people who would join the channel would not get the @ by their name. The @ by your name meant that you were a channel operator. So if you were a channel operator, you had the ability to give other people opt rights. So you could opt somebody, saying, okay, well, let me make this person an operator in the channel. They're able to do the same thing that I can do, which is ban a user, kick a user. You could get people out of the chat room if they're misbehaving, acting inappropriately or not in accordance with the rules of the channel. Or you could also do things like DCC files, and you could like send files. You could run something called an fserv where people could upload and download files. All kinds of stuff that you could do in there. You could ping people, trace routes to people. You have all this network capability to see if a person was around or not. Now, what would happen is the channels would get too busy, right? So get really, really busy, and then you'd have something called a net split where we all got kicked off. So we all got booted off. Now, if someone, when we all connected back, if someone joined the channel before me, I would lose my channel. So after a net split, if I didn't register my channel to keep my channel alive and register myself as an operator in the channel, I would lose the channel. So what people started to do is people started to write software that could log into the channel So this would be this IRC bot software, often called an egg drop, that would log into the IRC server, log in as a legitimate user, and then give up rights to everybody else that was registered as an operator. Now this bot would do things like give people the requisite files for the server, hand out the new encryption keys for the chat room, or all kinds of things that you would want a regular administrator to do, but you would write software that did it for you. So this IRC bot could, give things to anybody who joined the channel, or check connectivity of connected users, have they connected to the channel and have we lost connectivity to them. So people got the bright idea of, hey, this is great. What I can do is every time I hack into somebody, I can install IRC client software on the machine I hack into. And then I can use the IRC bot that's sitting in the IRC channel to push commands to that IRC zombie or victim, if you will, who connected to the channel, this hacked person. And this is where the term botnet came from. So you're more than likely looking at some botnet software right now. This is a bot. This is an IRC bot. So the thing to do here would be to try more IRC stuff. Okay, we've got join. Do we have admin? Okay, don't have admin. Do I have list? Don't have list. So what you would want to know is, do you have the ability to list? If you could list, you're probably the IRC C2, command and control, because you can list all of your connected users. So that's not what this guy can do. So you notice, so far, the bulk of this command line malware analysis is going to be how well we can look up DLLs and how well we can look up things like IRC commands. And that's what this list is here. So let's go ahead, let's take a break. Let's take about 15 minutes, and let's come back and let's do some more.